Okay, this is the video for 2023 WA2. I hope you have used this for your revision. Okay, I'm going to just go through the answers. Okay, so question 1, gravitational field strength. So you need to know the definition. Okay, it's in your notes. On the surface of two planets. So one of them is 3.7 for Mars, the other one is Venus 8.9, and the unit is Newton per kg. Now a rock has a weight of 46 Newton on Venus. So I will say W Venus equals to 46 Newton. Okay, they want us to find the weight of the rock on Mars. So WV equals to mass. Since mass do not change, but the gravitational field strength changes for Venus, I'll write as WV, which this is to show is for Venus, equals to mass times gravitational field strength of Venus. So 46 equals to mass. Okay, I want to find the mass. I'm given the gravitational field strength of Venus. So my mass is going to be 46 over 8.9. Alright. And since mass doesn't change, I'm going to do another calculation for mass, mgm. Okay. So weight of the rock on Mars is what I need to find, and I'm going to use back the same mass because the mass doesn't change. The weight changes because of different planets having different gravitational field strength. So over here you need to choose the correct gravitational field strength, and the answer will be around 19 Newton. So answer is B. Okay, please check your answer. Okay, then beakers shown contain 3 different liquids. Which statement about the densities of the liquids is correct? Now, density formula equals to mass over volume. Okay, so we are provided with the mass and volume. So for liquid 1, the mass is 100 grams over 100 cm cube. So it's 1 gram per cm cube. Similarly for 2, it is also 1 gram per cm cube, and for 3, liquid 3, it is 100 over 50, so equals to 2 gram per cm cube. So let's look for the correct option. They want us to choose the correct option. Liquid 1 has twice the no. Liquid 3 has twice. This is true, but let's check the other options. Densities of the 3 liquids are all different. Not true. 1 and 2 are the same. They are the same. Not true. So answer is B. Alright. Now question 3, it shows a hydraulic press. What is it? Doesn't matter. Let's read on. That is used to lift a car. In the hydraulic press, pressure is transmitted equally to all parts of the enclosed liquid. That means whatever pressure over here will be equal to the pressure over here. Right? This is how the hydraulic press works. Okay, then we take note there's a force here, 2000 Newton, and there's a cross-sectional area of 0.4. Now, when they say pressure, that means you must already think of pressure equals to force over area, this formula. Okay, then on the other side, we also have another area. Maybe I call this A1, I call this F1. Alright, over here will then be my A2. Okay, they want us to find the maximum possible weight of the car, which I can call it F2. Since pressure is the same, right, is transmitted equally provided by the question, can I then say P1 equals to P2? P1 is over here and P2 is over here. Okay, if P1 is equals to P2, then F1 over A1 will be equal to F2 over A2, because P1 is equal to F1 over A1, P2 is F2 over A2. And since we have 4 variables here, 3 of them I know the numbers, I can just substitute in. 2000 over A1 is 0.40 equals to F2, which is unknown, over A2, which is 8.0. So be careful and label them correctly so that you can substitute them in correctly. So answer is 40,000. If you do your math, F2 equals to 2000 times 8.0 over 0.40, you get an answer of 40,000 Newton. Okay, question 4. If I look at pulling blocks, I will know it's dynamics, right? So on a smooth horizontal ground, please read the question. This means there's no friction, all right? If there's no friction, then they are being pulled by two forces, S1 and S2, so 60 Newton and 80 Newton. Straight away, I will know the F net is 20 Newton. Still remember how to represent F net? I will need to draw a double arrow and with the magnitude pointing in the right direction. Okay, so we always take the larger force minus the smaller force. And the block accelerates 2.5 meter per second square to the right. Right, so my F net is consistent in that direction. So I have acceleration provided. Okay, so formula is F net equals to MA. Now my F net is 20, my mass is unknown, my A is 2.5, therefore my mass will be 8 kg. Okay, take note, this is a SI unit formula. So everything has to be in SI unit, including the mass. So if I give you the mass in grams, remember to change it to kilograms. Okay, question 5, I still see wooden block, and it is actually being pushed along a rough surface and moving at constant speed. So this statement is very important. That means over here, there is friction. And how much is the friction? Based on this constant speed theory, my acceleration is 0. If acceleration is 0, that means I can think of my F net to be 0. But I have a pushing force against a friction force, so I can deduce that the pushing force is equal to the friction. Equal and opposite. That is why they cancel each other to result in F net to be 0. And by formula F net equals to MA, my acceleration is 0. That means it must move with constant speed. So now it is moving from rough to smooth. For smooth, there is no friction. Okay, so if there's no friction and the pushing force is the same, so now if I were to draw this here, I have a pushing force here, but the friction is no longer there. So this F actually becomes my F net. So when it goes over to the smooth surface, on the rough surface, F net was 0 because there was friction that was equal and opposite to the pushing force. But now when I go to the smooth surface, the question tells me, so my horizontal pushing force becomes F net because there are no other opposing force. So if there's F net, that means it will have acceleration. Okay, so answer is A. Question 6. A block of wood is at rest. That means it's not sliding down. Because it's on a slope, by right, it should be sliding down. So, if I have the wood like that, and if let's say there's no friction, the block will actually slide down this way. Therefore, friction must be this way. So, this is incorrect. This is incorrect because friction must oppose the direction of the force. So, that means it's either C or D. Now weight is always vertically downwards, then normal force, it must be perpendicular, so answer is C.